Welcome students. So welcome to the next topic. Today's topic is how we can solve horizontal table mass pulley system. Now there are few assumptions as well. So as in that case we take a frictionless table, and also we are taking a frictionless pulley. Okay, and one more thing, the string which is attached to the pulley is always going to be inextensible, which means it's not going to have any kind of elasticity. So we are neglecting those properties to cover up that topic. Okay, now many numerical problems in IIT, NEET and B.Ed comes as that numerical problem. How you can solve all those problems is going to be very easy. Now I will teach you how you can make a free body diagram out of that. So if we are taking a mass m1 here and taking a mass m2 here, and we are going to take m2 as greater than m1, which means that is why that system is moving downward here. Now if that system is moving downward with an acceleration a, so which means the mass m1 is also moving horizontally with the acceleration a. Okay, and always remember one thing, the tension in the string is always going toward the pulley, which means if we are going to mention the tensions in the string T, and here is also going to be T here. Okay, now these two are the tension in the strings. You can also make the weight which is going to be, now m2 is going to have a weight, let's assume w2, and here's weight is going to be w1 here. Obviously that is also going to have some kind of normal direction as well, so that is going to be the normal direction r here. Now that is going to be our diagram right now. Okay, now how we can solve the case for acceleration, and how we can make a shortcut formula to solve all the MCQs. So that is very easy concept. If you are going to make a diagram like that, and if you are going to make the directions of tension, directions of weight and direction of acceleration, if you are going to mention that, then that topic is going to be quite easy. Now first of all, see here, that block is moving horizontally toward my left to right, so which means there are no vertical forces acting, which means the vertical forces of w1 is cancelled out by the r, which means there is no vertical force acting, only horizontal force is taking place. That is why that block is moving toward the pulley, so which means that is going to be very easy here. So for you can take block m1. now for block m1, that is going to be very easy right now. Okay, so F is always going to be equal to tension in the string. Now that is going to be the tension in the string. Now what is going to be the F? So obviously that is the force with which that block is moving toward the pulley. So these two are always going to be equal, because vertical forces are cancelled out, or you can say neglected as well, because that is moving horizontally. That block is moving only horizontally toward my left to right, so that is why it is taken like that. So that should be taken as equation 1 as well. And you all know what is the formula of F, Newton's second law. According to Newton's second law, you know, F is going to be equal to m1a, so which means that equation can be termed as m1a is equal to t. So I am just mentioning that equation here. Okay, now we are going to take similar thing. We are going to take similar thing for the second block as well. Now check out that block. That block is moving downward. So if that block is moving downward, so now we are going to make the expression for m2. Obviously if that block is moving downward, so w2 is higher than the t, obviously is greater than the t, because it's moving downward. So it's very easy. From that you can easily assume that if it's moving downward, so W2 is going to be higher than the tension T in the string. That is why it is moving downward in downward direction. So which means net force is going to be equal to, yes, W2 minus T, as in the simple case of mass pulley system. Now the net force is always going to be, that is for the second mass, so that is going to be, yes, M2A is equal to W2 minus T, and that should be marked as equation number 2. Now if you want to calculate the formula for acceleration for the system, so you can just add those equations and you will have the answer. So adding equation first and second, now what you have, M1A plus M2A is equal to, yes, T W2 minus C. Now the T is cancelled out and you can take A common from here, that is going to be M1 plus M2, and you can also put up the weight value. Now what is weight? Weight is always going to be equal to, yes, mass into gravity, which means you can take it as M2G, and that is going to be the formula of acceleration here. So that is going to be M2G upon M1 plus M2. That is the required formula for acceleration. That is how you can solve all types of numerical of acceleration of horizontal table pulley system. Okay, now if you want to calculate the tension, you can put up that value of A in equation 1, then you can easily make the formula for tension as well, which means therefore equation 1 becomes, now you can put up the value of A here, so that is going to be the formula for T, which means that is going to be M1, yes, and now multiplied by M2G over M1 plus M2, so which means T is going to be equal to M1 M2G upon M1 plus M2. Now that is the formula for tension in the string. Now in any kind of numerical, any kind of MCQ, if you want to calculate the acceleration, you can directly use that formula, or if you want to calculate the tension in the string, you can directly use that formula for any system like that. Okay, so hope you are understanding that, and I am PS Bakshi, and if you are like that video, then subscribe our channel as well, and you can also share to some other students, science students as well. Okay, so thank you so much and stay blessed, be happy.